Welcome to the viewers. Now we discuss a convergent sequence. Is a cauchy sequence. But converse is not true. Then how to solve this? We have to prove at first this convergent sequence. Let xn be a convergent sequence actually this convergent sequence in a metric space, all it happens in a metric space. In a metric space xd, the bidividual matrix, since it is convergent, so limit as n tends to infinity xn, that's converging to a point, suppose say v, that belonging to x, obviously. Now we have to prove this is a cauchy sequence. Converse is not true actually in a metric space. And we have to prove this result. How to prove this result? If we prove this result as a cauchy sequence, so it's convergent. Now we use d of since it is convergent, so d of xn v, that's less than epsilon by 2 whenever n is greater than equals to n. For a given epsilon greater than 0, we find capital N. Here in this way we construct. And now for given epsilon greater than 0, we find index n such that d of vxm, mn is arbitrary elements, is less than epsilon by 2 whenever this m must be greater than n. Therefore d of xm xn, that will be less than equals to d of xm v plus d of vxm. Simply both have the same property, vxm and xmv all are less than epsilon by 2 plus epsilon by 2 whenever, that is mn is greater than equals to n. That is d of xm xn, that is less than epsilon whenever mn is greater than equals to n, which shows mn greater than n, that imply mn tends to infinity, then d of xm xn, that tends to 0. that is limit as mn tends to infinity d of xm xn, that will be equals to 0, which shows xn is a cauchy sequence. But converse is not true. If we see an example, xn is a sequence which satisfy cauchy criteria, in the interval 0, 1, that is closed open status. Let us take xn equals to 1 by n belonging to the natural number, that is 1, 2, 3, 4. And now d of xm xn, that will be equals to mod of xm minus xn, which is equals to mod of 1 by m minus 1 by n, that is less than 1 by m plus 1 by n. And as n tends to infinity, there are the criteria. If we consider two type of criteria, if we consider either analytic definitions or simple treated as limiting conditions, we see in this manner, and certainly that will be tends to 0 as mn tending to infinity, that is limit as mn tending to infinity d of xm xn equals to 0. So xn is a cauchy sequence but xn is equal to 1 by n is not convergent in this open semi-open closed interval like close open 0 to 1, and obviously it is a divergent sequence. Because this is a harmonic sequence, we know, and every discussion, detailed discussions, we refer and suggest to follow real analysis how this is a divergent sequence. But here in the metric spaces we only considering the example without proof how this is divergent sequence. That detailed discussion will be on real number systems and real analysis, that will be referred to real analysis. So it is not convergent. That's a harmonic sequence, it is divergent, and so we can say every cauchy sequence may not be convergent, but convergent sequence must be a cauchy sequence. So in this way we prove this result. We end our discussion today. If you like this video, like it, share it, don't forget to subscribe the channel. Thanks for watching.